Guys, we'll wait 2-3 minutes for others and then we'll start. Okay? Good evening, students. Welcome back. Yes, we are going to start with probability. I hope you attended the last lecture. Last lecture we talked about, we'll be starting with new chapter, which is probability. So here, this chapter or what we are going to do today is the introduction, then basic terminologies, what is a sample space, what is an event, and types of events and such definition of probability, and then we'll do some question. So starting of the lecture will mostly be theoretical part. As you can see, these three parts are basically theory part. So please be with me. Uh, Understand what is the theory part, and it will be a great help if you recall some of the things we did in sets. So sets and probability go hand in hand. If you remember some definitions in sets, we can easily get through in probability. So yeah, please be with me. Starting में we have many theory to cover. So let's say introduction. So first introduction में we have a random experiment. I hope you know what is meant by random experiment. Whenever in probability we are doing random experiment, that means a coin is tossed, a die is thrown, a card is drawn. So such experiments are called random experiments or trials. So you can see, read this theory and you can get a grasp of what is an experiment. As in physics and chemistry, the experiment is different, right? But in statistical experiments or in mathematical experiments, the meaning of experiment is different, which we are going to talk in this chapter. Next is why random experiment. What is the meaning of random? So it is a very significant meaning, which is the result is not certain, but it may be one of the several possible outcomes. That means whenever we perform an experiment, we'll have several outcomes. So out of that several outcomes, we will get one of the result. But which result we'll get, it is not certain. Such an experiment is called a random experiment. You can see the examples here. That is, if I toss a coin, so if I toss a coin, I'll either get head or tail. But which I'll get when? That is, whether I'll get head every time or whether I'll get tail or whether I'll get 50%, 50% every time. That we don't know. That's why the name random experiment. You can see the second example is throwing a die. So either throwing a die, I can get a fixed number of outputs. That is, either I'll get 1, 2, 3, 4, 5, or 6. But which I will get when, that is not possible to tell. That's why the chapter probability exists. Right? So let's see the next definition, which is the sample space. Now, sample space is the set of all distinct outcomes. As we have seen that in previous example, when a die is thrown, we have number of outcomes, that is 1, 2, 3, 4, 5, 6. So this 6 outcomes, when we put it in a set, they become sample space. Correct? And N of S, this is read as N of S. N of S denotes the number of elements in the sample space. So let's see example, a coin is tossed. So if a coin is tossed, we'll get two outcomes, which is head and tail. And if S be the sample space or sample set, that will be head, comma, tail. The number of elements are 1 and 2. The number of elements are 2. Very easy to understand. And also, I hope you have done the chapter probability in 10th standard, right? You all must be the ones, or everyone is the one whose favorite chapter is probability in 10th standard. Even my favorite chapter was probability when I was in 10th standard. So I hope you are thorough with all these definitions. So if two coins are tossed, if two coins are tossed, then I'll get 4 possible outcomes, which is given by 2 square, which is 4. So this can be generalized. If 3 coins are tossed, then this will be 2 cube, right? 2 cube. If k coins are tossed, then 2 raised to k. So we generalize it in terms of coins. What we generalize, the number of elements in sample space, which is given by n of s. Let's see what we have next. Throwing a die, throwing 2 die. I hope you know this favorite or famous sample space when 2 dice are thrown. That is 1 1 1 2 1 3 1 4 1 5 1 6 2 1 2 2 2 3 2 4 2 5 2 6 until 6 1 6 2 6 3 6 4 6 5 6 6. This was a famous sample space which you studied in standard 10. Correct? Let's see what is n of s. It will be 6 square, which is 36. So this can also be generalized if die is thrown one time, single die. Then it is 6 raised to the power 1. If two dice are thrown, 6 raised to the power 2. Three dice are thrown, 6 raised to the power 3. So k dice are thrown, 6 raised to the power k. Correct? Let's see. Okay. So here is urn. I hope you know what is meant by urn. Urn means simply a bag. You can consider it as a bag. Uh, Contains 3 white, 4 red, and 7 green balls. So total number of balls are 14. And if 5 balls are drawn at random, I hope you know what is meant by 5 balls are drawn. I hope you are familiar with permutations and combinations. So if I have to select 5 balls out of 14 balls, I can select it by 14C5, which will be my sample space. So let's see an example or an MCQ here. Yeah. When a coin and a die are rolled, then N of S is. When a coin and die are rolled together, then number of sample space. So I hope you have thought about this. A coin has N of S 2 and means multiplication. Die has sample space 6. So if you are familiar, that's why I was telling, if you are familiar with the sets uh, logic, that and means multiply or means add, so then it will be very simple. We just have to multiply 2 into 6, which is 12. So the sample space when a coin and die are thrown together is basically 2 6 are 12. Correct? Let's define what's an event. Now, in technical terms, an event is basically subset of the sample space. But in word problem terms or in literature terms, that means the thing or the outcome that we expect. Let's say, suppose I throw a single die. So I'll get 1, 2, 3, 4, 5, 6 as outcomes. Now, suppose I expect the die to show the number 6. So that becomes an event. So what is the experiment performed here? The experiment is a die is thrown. What is the sample space here? Sample space is 1, 2, 3, 4, 5, 6. What is the event here? Event is I require the number 6. So the number 6, appearance of number 6 is the event. Right, guys? So this is defined as an event, and logically or mathematically, event is always be a subset of sample space. Events are denoted by capital letters A, B, and C. Just as sample space is denoted by capital letter S. Let's see. By throwing a simple die, the sample space is 1, 2, 3, 4, 5, 6. Now these are A and B are two subsets of this sample space. That's why they are called events. Correct? This is the technical definition. The mathematical or physical definition I told you all, which is what is meant by event. The outcome we require is called event. Let's see what we have next. Come on. 4. Acha. If you saw the subset A, subset A had even numbers 2, 4, and 6. That means event of getting an even number is basically A. And if you notice, subset B had odd numbers 1, 3, and 5. So event and getting an odd number is B. Let's look at the other example. I'll move aside so you can read it. 4 cards drawn from a pack of 52 cards. Let the event be that all 4 cards are red. Then N of A will be 26C4. Because if you know, out of the 52 cards, 26 cards are black, 26 cards are red. Now, event is we want the red cards. So out of 26, I have to select 4 cards. That means my N of A will be 26C4. Correct, guys? Let's see the next question. Let B be the event which have the same face value. I hope you know what is meant by face value. Face value means face cards. Face cards means, I think, assume that B event all 4 cards have the same face value. Face value means basically the same number. That means all the 4 cards should be either 2, 2, 2, 2. That means 2 from spades, the number card 2 from spades, the card 2 from hearts, the card 2 from diamond, and the card 2 from, I think, spades, and other we have leaf one, right? I don't remember the name. I think spades and spades is like the flower, right? Not the flower. This is a spade, the tree, right? So we want the face value should be same. That means either all 4 should be A, either all 4 should be kings, either all 4 should be queens, and so on. So we know that total face cards are 13, not the face card, the same face value card. So if I want to choose 4 out of 13, then it should be 13C4. Correct, guys? 13C1 is it is, right? Why did I write 4? 13C1. Now, let's see what we have next. Certain event and impossible event. Now, certain event means a event which is bound to happen. That means no matter what you do, that event will happen. And impossible event is exactly the opposite. That means whatever you do, the event will not happen. So very simple to understand. Let's see an example. So if I took the example here, when a usual die is rolled, that means a die which has 6 numbers 1, 2, 3, 4, 5, 6. When a usual die is rolled, then getting a multiple of 7 is an impossible event because it is not in the sample space. Hear me out. An event will be impossible when it will not be in the sample space. So here 7 is will not be in a sample space. That means 7 will be an impossible event. And getting a number less than 7 will be a certain event. Why? Because every number in the sample space is less than 7. That means I am bound to get the number less than 7 whenever I throw a die. That means this is a certain event. Complement of an event. Complement of an event. I hope you have heard complement of a set. What is meant by complement of a set? The same thing is meant complement of a event. So let me tell you, complement of a event and complement of a set are same. So let's say, suppose S is the sample space and let A be any event. So we know that A is a subset of S. That means the complement of A will be the whole sample space minus whatever it is in A. That is, whatever that is outside of A, but inside of sample space. I hope you know this diagram. This box represents sample space. This circle represents event A. So anything and everything which is outside of A, but inside of sample space is called complement of A. Is called complement of A. So welcome guys, welcome you all. I hope all of you all have joined. Nobody is remaining. Hello Sujit. You all are very late. I think there was some problem or not. Yeah, you can see. Just a second. I don't know. Just a second, guys. Yeah. As you can see, example, if a die is rolled, then the sample space is this, as you all know. Let's say, suppose event A is 3, 6. Then what will be the complement of A? The complement event will be the numbers which are not in A. That means 3 and 6, but which are present in the sample space. So apart from 3 and 6, what are we left with? 1, 2, 4, and 5. So this is my answer, which is A complement. Correct, guys? Let's see the next one. Okay. Second example is, if a card is drawn from a pack of 52 cards and A event is getting king, then A complement. I hope you know how to read it. The notation is A and bar or A dash or A complement. These are the same notations we used in 6. So A complement is the event of not getting king. A complement will be the event of not getting the king card. Correct? So A will contain 4 sample points. Why? Because there are 4 kings in a pack of 52 cards. And the remaining 48 will be not containing the king. That's as simple as that. Let's see, note De Morgan's law. I hope you have studied this in sets also. That is, A union B the whole complement is basically equals to A complement intersection B complement. And similarly, A intersection B the whole complement is equals to A complement union B complement. I hope you remember this from sets because I am not really gonna go dig deep into this. Just remember the De Morgan's law. It will help us somewhat in solving the question. Right, guys? Come on. Compound event. That means when two events, as you can read, when two events A and B are occurring simultaneously or together, both the events are called compound events. That is A intersection B, A union B, and so on. So the compound events is basically the union and intersection, right? And we know that A intersection B means A and B should occur simultaneously. Let's say, for an example, here we have a card is selected random from a pack of 52 cards. And let A be the event of getting the red card, right? Let's see what we have next. Next is let B be the event of getting the king. Now, intersection corresponds to AND. I hope you know this from sets logic. Whenever we have intersection, that means it is AND. And whenever we have union, that means it is OR. I hope you can correlate this with the sets logic because in sets also we did the same thing. So here, event of getting the card as king and event of getting the card as red will be the A intersection B. That is, card is red and king. Correct? This is basically the language I'm trying to show you how the language comes in the question. So you can convert it into right mathematical form. That is, if and comes and corresponds to intersection, or comes or corresponds to union. So we have N of A. N of A means the card should be red. So from 26, I mean total cards from 52 are 26, which are red, and 26, which are black. The red cards will be 26, and event A will be 26C1. Similarly, event B, you can say event B is king. So total kings are 4, and out of those 4 kings, we want 1. So we can select it by 4C1. N of A intersection B. What will be N of A intersection B? The card should be red as well as a king. That means the card should either be king of diamonds or king of hearts. King of diamonds or king of hearts. So we have 2, right? Come on. Let's see what we have next. Mutually exclusive events. Now, what is meant by mutually exclusive events? Mutually exclusive events means A intersection B. Let there be 2 events, A and B, and if A intersection B is a null set, then these are called mutually exclusive events. Let us see the example here, guys. Uh, if a die is rolled, then we know S is equals to 1, 2, 3, 4, 5, 6. Correct? This is a sample space. Now let A be the event of getting an even number. And let B be the event of getting an odd number. Then the set A will look like 2, 4, and 6. The set B will look like 1, 3, and 5. Now, as you can see, there is nothing common in both the sets. That means A intersection B is a null set. That means A and B are mutually exclusive. Correct? Now, I hope you have heard disjoint sets. So mutually exclusive events corresponds to disjoint sets in set theory. Correct, guys? Let's see what we have next. Equally likely events. Equally likely events. Let me tell you in very robust way. Equally likely events means the probability of both the events happening is same. The probability of both the events happening is same. That means no event gets priority to happen. That's what it is given here. If there is no reason to expect any one of them to happen, in preference to others. That means probability of both those events is same. Let's see example, it will be more clear, guys. Acha, any doubts here? Whenever you all have joined, I think Sujit joined the earliest, and then the rest came, right? So, is it clear till here, guys? I'm just fast forwarding through the theory part. I hope you are comfortable. If you have any doubts, you can ask, right? Sujit, De Morgan's law, there is no such importance of De Morgan's law in probability. They are basically used in sets. So we'll ignore it for now. I just included the De Morgan's law here because it you can relate it with the set theory. That was the only purpose. But no use of using the De Morgan's law here. We'll see it in the set theory, or we have already seen it in the set theory. If you didn't understood, don't worry, guys. And what about others? Are others comfortable with the theory part, how we are going? Or should I explain some once more, or should I slow down, or should I skip it and directly we'll go to the questions and all? All of are good? Give me a thumbs up, guys. Sujit, okay, okay. Sujit. Okay, fine, fine. If you have any doubt where, just stop me, write in the chat box. Okay, okay. We'll go through the theory one by one slowly. Okay, guys? I'll give you time to read it and then I'll explain, right? That'll be fine, I guess. Chalo. So I guess equally likely events you have read. Let me read it. Two or more events are said to be equally likely, or you can say equiprobable. That is what I was trying to explain. Equiprobable means the probability of both the events happening is same. That means no event gets priority over the other. Now, if you see the example, you will see. The example says if we throw a die, then the probability of every number to be there. What are the numbers? 1, 2, 3, 4, 5, 6. So the probability of all of these numbers coming on the die is all the same. Let me give you a simpler example. Let's say we toss a coin. There are only two possible outcomes, head and tail. Now, head and tail both are equiprobable because the number of times head will come, or the probability of head will be equal to probability of tail. And if you know probability of head is half, probability of tail is also half. That means both are equiprobable. Correct, guys? Let's see what is exhaustive events. Exhaustive events is nothing but let's say, first we'll read it, then I'll explain. Two or more events are said to be exhaustive if I don't think any one of y'all understood the what it is trying to say, the theory part. Don't worry. Uh, Let me explain and then again read it. So then you'll be easily able to figure it out. Exhaustive events, let's say we have k number of events. 1 से लेके k. That means we'll have k subsets, that is E1, E2, E3, E4, E5 and so on. So if we add all those subsets, or if we take union of those subsets, and by taking union I get sample space, then those events are exhaustive events. Let me repeat it again. For simplicity, let's say we have two events, and when I take union of both the set of events, I get the sample space. Such events are called exhaustive events. I hope now you understood the meaning. Let's see the example. Two coins are tossed. If two coins are tossed, the sample space will be this. So we have defined three events, A, B, and C. Event A is getting two heads, B is getting one head, and C is getting zero heads. So the set A will look like two heads, only HH. Set B will look like one head. And set C will look like no head, that means only tail. And if you take the union of A, B, and C, I'll get all of these elements, and all of these elements belong to S. So A union B union C is equals to S. So such events are called exhaustive events. Let me tell you, the exhaustive events can be two or more than two. Let's see what we have next. We have the famous definition of probability. Now let me simplify it for you. Yeah, Sujit. Yeah, very good correlation. Subsets of power set. Super. So power set you can consider as sample space, and their subsets you can consider it as uh, all of those events are mutually exclusive, because when we take the unions of all those subsets, then we get the power set. Superb. Nice. Come on. Now let's not go through this definition. Let me give you a simple definition. Basically, probability of anything, it's basically given by favorable outcomes upon total outcomes. This is a classical definition of probability, that is favorable outcomes upon total outcomes. Correct? Favorable outcomes means the outcomes I wish to have, and total outcomes means the total outcomes that are possible. So, in simple terms, the total outcomes is always equals to sample space, and the favorable outcome, let's say the event is A. So favorable outcome is always equals to N of A. Clear, guys? Total outcomes will always be equal to the total sample space, and favorable outcomes, let's say we have the event A which is favorable to us. That means the favorable outcomes will be N of A. This is the basic definition of probability. I hope you all know this, right? Uh, Yeah, we have already done this. N of E is the number of sample points of favorable events, that is N of E, and N of S is number of sample space. Now let us go through some notes here. Obviously, probability will lie between 0 to 1, because no probability can be negative and no probability can be greater than 1. It is very simple to understand. Second is, if a probability is of an event happening is 0, that means that event does not happen. And if an event does not happen, not does not, cannot happen. If an event cannot happen, no matter what, then such events are called impossible events. I hope you remember impossible events. And if P of E equals to 1, then it is a sure event. Sure event means that event is bound to happen no matter what you do. That means its probability will be 1. These are some common points. Chala. Now we'll start with some questions, and firstly we have some MCQs, very simple basic level. You know our format of the lecture, just to revise or go through what we studied till now. So fatafat, give me some answers. Come on, guys. What are the options here? 2 coins are tossed, then probability of getting 2 heads. B. Navya Manikanda, superb. Yes. B. I think we did this example, right? Only H and H will be there. H, the two. when we said exhaustive events. Okay, sorry. Yeah, this is good. I mean, obviously, this is not as good as that will appear in JEE main, but yeah, this is the best question you can get from 10th standard. Okay, somebody already got it. D, D. Superb, superb, guys. Yeah, it is D. Why? Getting same number means either we can get 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, or 6, 6. That will be 6 by 36, which is 1 by 6. Only 2, 3 people are giving the answers. If others are not understanding, please let me know so I can explain it again. But many of them are giving answers, so I guess you all are understanding. Chalo. There is a hint, but I would not like to give you a hint. Read the question and tell me the answer. Hmm. Two cards are drawn from 52. One of them is black and other is red. Nice question. And what is the meaning of and? And corresponds to multiplication. No one, should I do it? The sample space will be 52C2. Why? Two cards are drawn. Let A be the event. One of them is black. How many of are black? 26 are black. We want 1 out of 26. And corresponds to multiplication. 26 are red. We want 1 out of 26 again. So this is for black and this is for red. So what is the probability of event A? It is simply 26C1 is 26 into 26 upon what is 52C2? 52 into 51 upon 2, right? So 26 ones are 26 twos are. This and this two will get cancelled. So my answer will be 26 upon 50. I hope it is clear. All good, guys? Please see the calculations. Give me a thumbs up if you understood it. Okay, superb, guys. Chalo. Yeah, now we'll look at the questions. Equally likely. What is meant by equally likely? That means they all have the same probability. So check whether events A, B, and C have the same probability and give me an answer yes or no. Are they equally likely or not? What is my answer? Yes or no? Yes. Yes, yes. Superb. I think everyone of you got throwing a die. Die means n of s is 6. And here 3. Here number is 3. Here number is 3. So the probability is 3 by 6, 3 by 6, 3 by 6. So 1 by 6. That means yes. Let's see next. Yeah. Two numbers are selected from 20 consecutive natural numbers. This is a good question. Two numbers are selected from 20 consecutive natural numbers. So let's take the natural numbers as 1 to 20, right? Find out that the sum of the two numbers is even. Let us first write the sample space. How many natural numbers are there? 20. How many we want? 2. So N of S will be 20C2, which I guess is 190. Right? Now let's do the first one, even number. Sum should be even. Now, let me tell you one very common thing. The sum of two numbers will be even only when both the numbers are even or both the numbers are odd. Got the answer? Half. Uh, I think I don't know the answer. Let's see. Implies both numbers will be even or odd. Now let me tell you, odd corresponds to addition. Let's take this is case 1 and this is case 2. So case 1, both numbers are even. So how many even numbers are there in 20 natural numbers? So 20 natural numbers, 10 will be even and 10 will be odd. And we want both the numbers to be even. That means I have to select 2 from the 10 even numbers, and case 2, I have to select 2 from the 10 odd numbers. This means both the numbers are even. This means both the numbers are odd, and OR means add. So if we add this, 10C2, I think is 45 plus 45, which is corresponds to 90. So what probability we got? Probability of 1. Question number 1, this is not I, okay, is 90 upon 190, which corresponds to 9 upon 90. So your answer was wrong, Sujit. Half. 0 and 1. What is meant by 0 and 1, Akhil? What is meant by 0 and 1? What are you trying to say, Akhil? Okay, did you understood, guys? All of you guys understood this? What we are going to do? Give me a thumbs up if it's clear, guys. Manikanta is saying okay. Navya is saying oh. Once again, Sujit wants once again. Okay. What we are doing, guys? First, let me tell you. Did you understood that we will get the sum of two numbers as even only when both the numbers are even and both the numbers are odd? What I'm trying to say is, if let's say two numbers are x and y, and if we add x and y, I get an even number. So it is only possible when x and y both are even or when x and y both are odd. Let's say suppose for example, I want x plus y equals to 8. So I can get 8 when x is 1, y is 7, both are odd, or x is 3, y is 5, again both are odd, or x is 2, y is 6, again both are even, or x is 4, y is 4, again both are even. Did you understood this? Give me a thumbs up if you understood what I'm trying to say here. Okay, Akhil and Sujit. Okay, fine. So I hope you understood that. Let's see in sample space 1 to 20. Now, if you count 1 to 20, 1, 2, 3, 4, 5, 6, 20, we'll have 10 even numbers and 10 odd numbers. What will be the even numbers? 2, 4, 6, 8, 10, 5, then 12, 14, 16, 18, 20. So 10 even numbers and remaining 10 will be odd numbers. So we have two cases. Either both the numbers can be even or either both the numbers can be odd, as I explained here. So for case 1, let's say both of the numbers are even. If both of the numbers are even, that means we have to select from this 10 only, because there are only 10 even numbers in 20. So if I have to select two even numbers from 10, I can select it by 10C2. Similarly, for case 2, I want to select two odd numbers. There are 10 odd numbers. Now I want to select 10C2, same. And OR means addition. So we have to add these two. So 45 plus 45 will be 90. So this is the sample. This is the sample space. This is the event. That means 90 upon 190 or 9 by 19 is the probability. I hope you got it now, guys. Sujit, Akhil, superb. Chalo. So according to this logic, I can get the answer of second one. Let me rub this. Second one is odd number. Now, same logic. If there are two numbers and I want to add them and get an odd number, so that means one of them must be even, one of them must be odd. Let me give you a very simple example. X plus y I want as, let's say 7. So one of them must be odd, one of them must be even. One of them must be odd, one of them must be even. One of them must be odd, one of them must be even. I hope you understood this. So, sample space was 190. Event will be either x is even, y is odd, or either x is odd, y is even. I hope you are getting it. So, if x is odd, then I want one odd number from 10 and one even number from 10. And if x is even, y is odd, that means I want one even number from this, one odd number from this. Correct? 10 by 19. Yeah. Manikanta is very smart because as we saw, she used the complement of an event. That's also a very good way. Okay. Manikanta told directly 10 by 19 because uh, the sum of two numbers can either, let me tell you one thing. If two numbers are getting added, two natural numbers are getting added, their sum can either be even or odd. There is no other possibility. So if it is even number, we got 9 by 19. So what is the probability that it will be odd number? Complement, na? 10 by 19. Because 9 out of 19 times it is even number. So that is biologically means 10 out of 19 times will be odd number. Thank you, Manikanta. Uh, we got a very interesting method here by using the complement. I didn't think of it thanks to you. So we can, this is very simpler of what rather than what I was trying to say. Yeah, Sujit, very good. I hope you all got it. I think time is up. So we'll end our session here. I hope to see you on Monday. We'll continue with these questions on probability. Okay. Okay, guys. Bye bye, everyone. Take care. I hope you have all filled the JE mains and Saturday Sunday you have AIET. So all the best for that. And I hope you all have filled your JE mains forms. Okay. All the best for the AIET, guys. Bye bye. Take care.